ask all the speakers to come back up and to just take a few questions. So if you could just please come back up for a few minutes. And I also want to remind everyone that to conclude this World Congress, we are going to reconvene everyone in the room next door, which is the Benias room number 2, the center room. And David Scott will be providing some closing comments. So please stick around for that to conclude that. Now I'd like to open it up to questions. We have some microphones running around, and I encourage you to just please ask some questions to our panelists. Come on, somebody's got a question. Yes. Wait for the microphone.
Thanks. Hi, I'm Craig Howard, fire engineer at Bureau Happold. Just had a question for Michael about the pressurization system or the dilution system that you're proposing. It looks from the slices that you were drawing in smoke with a visibility of about 10 meters or 5 to 10 meters. And forgive me if I'm wrong, but I mean, I'm sort of sure at that point you might even get, toxic levels of smoke at that visibility, the fractional effective dose and whatnot. And I just wondered if you'd considered modeling a pressurized lobby and stair, or even a depressurized floor plate as part of your research.
I didn't do that as part of my research, and I agree that we have to take this much further. We have to look at the toxicity issues in full. I took a brief look at CO levels, but that's it. You also characterize us drawing smoke into the stair. We're not drawing smoke into the stair. That's the buoyancy pushing it into the stair, and then we're dealing with it once it's there. And all the architects want to do is pressurize the stair, but then it's being done wrong to potentially actually create a safety hazard. This is just a potential alternate that can be used, which I think is more effective. I think that for the super high-rise buildings and for the special cases, where you can put in lobbies, I'm a big proponent of stair vestibules, I'm a big proponent of elevator lobbies. I'm also a big proponent of having them co-located so that that same lobby can serve evacuation elevators and the stairs and be a protected space and ventilate it, much like it's being done at the Burj Dubai. But those systems aren't being done in the mid-rise buildings, and the architects are very stingy with space. So I'm dealing with when you can only do something in the stair, and that's your primary concern, and then the architects have put them on the opposite ends of the building. What can I do to avoid some of the problems that I've seen in the field, which I truly believe are safety hazards and just aren't being adequately addressed? Yeah, but it definitely needs more work.
Okay, next.
My name is Nagraj from Germany, practicing engineer. Question with your FDS model. You had one model where you had a leak door, and then you had smoke entering the staircase. How was the fire compartment modeled? Was it, I mean, there should be tremendous pressure to leak into the stair because the flow rate in the leak would have been quite a high speed, isn't it?
We put in, obviously, because when you're doing a model like that, you can't adequately capture the crack around the perimeter of a door. So we actually put in a low-level, just consolidated leakage. We also did the fire as a ramped up fire to steady state in the fire compartment. But we also had to add ventilation in that fire compartment so that the fire didn't go out.
But what was the pressure in the fire compartment? The pressure developed because we had a similar model tested in our office, and then we found that the pressure was so high that the window planes would explode at this pressure, because the windows would give in before the smoke enters the stairs.
We didn't run into that problem, and we actually modeled, you saw the curves that I showed from actual fire tests for unsprinklered fires and the pressures that they generate over the height of the space. We actually generated pressures in that similar range in the vicinity of 25 pascals, because we modeled the fire compartment with an appropriate amount of leakage. Some of the problems that happen is you model the fire compartment is very tight, and it's not realistic. Real compartments have real leakage.
Thank you.
Okay, one or two more questions? Anyone else? In the back? In the back?
I'm Antell, independent expert in fire protection. Question for the fire protection engineers who've been working on projects in the Middle East. Coming from a background of materials and testing of products and seeing what's being installed, we have a whole lot of knowledge and expertise to develop in the Middle East in terms of designing, installing, selecting products and fire protection systems and materials. We see all kinds of problems out there. The fire protection engineers are designing wonderful buildings out here, but what do you suggest we do to improve on what actually gets installed? Because all your assumptions and your models and your strategies are based on wonderful conceptual engineering developed in the Western world, where we have a whole lot of advanced system that oversees what gets done on the field. But here, we don't have that yet. So what's your solutions? The floor is open to all three fire protection firms.
Okay, I'll start first. Yeah, I have seen some terrible installations here in this country. I've seen fake sprinklers, I've seen fake fire dampers, I've seen fake ductwork, fire-rated ductwork. The only solution is to monitor those systems all the way through to completion and occupation of the building. You can't fire engineer the building and then let it go and not bother coming to take a look at it when it's finished. You have to complete that task. And a lot of the projects we're working on here, our clients know that, they respect that, and employ us to the completion of the projects so that we can monitor exactly what goes on in the installations, because, as I said before, I've seen some shocking installations in this country and in the Middle East generally. So it's not just here.
Yeah, I would agree that I think there's actually two elements to it. I think that as fire protection engineers and designers, we do have to be realistic about the quality and not only of the construction, but of the maintenance of systems and facilities over time. So I think we have to build that into our fire engineering, the failure modes and the probability of things not working. But I also think we need to continue to improve the construction process, to improve the quality of construction by monitoring projects as they come on board.
Okay, I think with that we will end it, because I kind of saw the hook sign back there. So I would like to close this with, we have some nice gifts for our speakers, and please give them a warm round of applause for a job well done. Also, I want to thank you, the audience, for attending this fine Congress, so please give yourselves a fine round of applause as well.